Hello everyone, my name is Weirong from UNC Charlotte. It's a great honor to present our work on Cluster 2020. The title of this paper is Data Life Aware Mode Updating Strategy for Stream-Based Online Deep Learning. This work is advised by Dr. Dazhao Chen. This is the outline of my presentation. I mainly divided into 5 sections. First, I will give a basic introduction on online learning and its current applications, and then the motivation of this work is provided. Our system design is discussed in the 3rd section, and then comes the evaluation part. Finally, this work will be concluded in the conclusion section. So let's have a look at the introduction section. So nowadays, deep learning, or DL for short, is very popular in both academia and the industry. Also, a lot of applications based on DL are developed in like pattern recognition, recommendation system, data mining, etc. Moreover, most DL applications are running in dynamic environments. The dynamic environments here can cover a lot of cases. For example, people speaking tone keep changing in speed and even syntax. User interests always shift in watching movies. Climate data is frequently changing in weather forecasting. These phenomena in dynamic environment is called concept drift. To tackle concept drift, for example, Google and Facebook adopt online learning in predicting advertisement clicks. Netflix uses a similar method in movie recommendation to its users or subscribers as well. However, the current solution on online learning is a little bit complicated because user has to manually design specific training loops, which is very complicated and time-consuming. Moreover, maybe more hardware resource is needed to guarantee the performance. So, are there any elegant and convenient method to implement online learning? Before answering this question, please let me give a quick review on the motivation to this work. Deep learning algorithms iteratively update the training model over training samples. It can be offline or online manners, depending on whether the whole training dataset is available or not. For online mode, the whole dataset is available, and the training is based on a batch of data samples, like this dataset. So here the capital S is the full data sample, covers a lot of data. While in online mode, training mode is updated with a single data sample, it's evident that it is lightweight and responds more quickly than offline learning. So this feature can benefit a lot in getting a better training models in the dynamic environment. So we did a case study on offline and online learning with 2 classic applications, convolutional neural network CN and deep neural network DN. So in this figure, we compare the training time. So those for online learning and those for offline learning. From these figures, we can see that the online learning is significantly faster than offline training. The reason is offline learning has to spend a long time to wait until all the whole data batch is available. In contrast, online training only uses new arrival data and doesn't have to wait for the moment that all data are available. Moreover, we also compare the performance in model quality. The left figure shows the overall perplexities of offline and online trainings. We can see they are very close, but the online manner is not so stable as offline manners. So while in the right one, it shows the model quality by offline training. So offline training, the model quality will keep increasing with more data available. However, the model quality by online training sometimes can outperform online manners like in the 10 and 40 time spot. So let us answer the question we put forward in the introduction section. So we introduced our solution called iDlaLayer. Before I give the detailed system design, I want to introduce a concept, which is a data life cycle. So we mainly divide the data into 4 data life cycles. It's already into 4 stages, which are newborn, which means the data is just arrived. Mature, which means the data contributes to the model updating and it works. Preserve stage represents that the data contributes a lot to the previous model updating and will be preserved for the next training loop. Discuss stage is the stage that the data make no contribution to model updating and will be discussed very soon. So this is the architecture of our proposed architecture. We name it iDlaLayer. It is a middleware between online learning applications and the backend framework. In this example, we use TensorflowOnSpark. iDlaLayer mainly includes 2 parts, a model controller and a data controller. Model controller is responsible for model training and updating, while data controller manages data samples. In model controller, it has 2 parts, training profile and updating controller. So you can get these functions from their names. Similarly, data controller covers 2 parts. One is the data classification and another is the data selection. Here is the training workflow of our work. So the first step, when a new data arrives, it will contact its exclusive client process running in the model controller to base the communication with our iDlaLayer, and then data information is transferred to the data controller. Then the data classification will judge and maybe maintain the data life stage of each data. And then updating controller is wake up to decide when and whether to launch model updating. Once updating decision is made in step 3, iDlaLayer will informs the backend system to do model updating. Meanwhile, in step 4, data selection is ready to send the combined data samples to the backend at the same time. So after the backend framework finish training model with new data samples, the updated model can finally be shipped to the model server system for further inference requests. So let's talk about the experimental results. Here is the experiment setup we use. So we use our local cluster with 15 nodes, and we use Intel Xeon E5 GPU. We have 64 gigabytes DRAM. We are running Ubuntu, Scala, and Hadoop. So we select 3 represent applications: MNIST, Criteo, and PageRank. This figure depicts the data ratio of different life stages on 5 randomly timed points from the 3 applications. We use stacked Instagram to denote the ratio of data life stages. 4 patterned columns represent the 4 data life stages we mentioned before. So at each time point, it's obvious that ratios of data life stages varies a lot because the solution to find the better data combination ratios changes over time. There are also a few conditions that data life stage doesn't show up in the combinations. For example, the time point 1 in MNIST and time point 4 in PageRank. The discarded stage does not show up because it makes no contribution to the model training. That's why they are not included in the combined data samples. Figure 5 also displays that these combinations of data samples keep changing at runtime, and each application shows unique behavior in terms of combination data samples. This is the effectiveness on training cost reduction. So in this one, we just do a simulation over 200, 400, and 600 data samples randomly selected from the data sites. From the figure, we can see with more data incorporated, the cost will also became higher, which is in combined with linear regression and relationship with data size and the training time cost. This figure plots the performance of a periodical and DLA. DLA is our method with iDlaLayer. So we can see our method can always outperform the periodical one. Then we compare the overhead between vanilla TensorflowOnSpark and our proposed method. Vanilla is for the vanilla TensorflowOnSpark and DLA is for iDlaLayer. So this figure depicts the training speed comparison. We can see our method is outperforms the vanilla one. So this one is a memory consumption. Our method is consuming a little bit more memory than the vanilla one, but it's negligible compared with the whole system size. Then I want to conclude our work. So in this paper, we propose iDLA, a middleware layer, to implement online learning. We propose iDLA is a novel model updating strategy based on data life cycles. And also our proposed method outperforms the vanilla system in overall elapsed time. So thank you for all your time. Happy to take questions.